everyone. Welcome to Crawl, Walk, Run, Growing Your AI Security Program. My name is Jenn Gile. I'm head of community for Endor Labs. And with me today is Chris Hughes. Chris, how about you introduce yourself?
Yeah, happy to be here. Chief Security Advisor at Endor Labs, and big advocate and evangelist around all things AppSec. So excited to have the conversation today.
Yeah, I think we're going to have a great conversation around kind of the three stages that at least we're talking about as you're tackling this big question that's probably coming your way. If someone has come to you and said, "Okay, what are you going to do about AI security?" And there's lots of sayings that apply to this. Boil the ocean, try to eat the whole elephant. So in this session, we're going to talk about kind of an approach you can take to figuring out what comes first, second, third. So in this crawl, walk, run model that we're going to offer up, we'll kind of talk about all three stages throughout. We'll spend most of our time talking about the crawl phase because it's going to be most broadly applicable to everyone who's watching. So that's going to be focused on how do you implement standards and tools to improve AI generated code security. And then the walk stage is, okay, great, you've dealt with the code security, but your developers are bringing in AI models and services. Perhaps your data science team is bringing them in. They're coming in, they're being called in your applications. How do you discover what's being used? How do you govern them? And then finally, for those who are already probably running really fast, how do you integrate security into your LLM development lifecycle? Chris, anything you want to say with commentary before we jump into crawl?
No, just a little joke that it wouldn't be AppSec or cybersecurity without a maturity model. But to your point, most of us are at the very beginning of this, trying to get up to speed when it comes to how we integrate security into this AI-driven development paradigm we're moving towards. So there'll be a lot of good stuff to touch on here, but I think there'll also be kind of a reinforcement of things that we know and have used in the past, but with a little bit of a twist of how they apply for AI.
Yeah, well said. And I'll say throughout my career, I've mostly worked with immature technologies. I kind of cut my teeth on Kubernetes and service mesh. And I'm very used to seeing technology adoption is usually those like really forward-leaning early adopters in the early days, and they go really deep and they learn everything, and then it trickles out to the rest of the market later. With AI, that's not the pattern that's happening, right? Everyone's jumped in feet first, and so that's where we are. So with crawl, this is, again, we're going to spend most of our time here because this is where a lot of people are encountering challenges right now. This is a tweet from back in March, which in AI years might be a decade. A lot has changed, but a lot has remained the same. And so this tweet is kind of summarizing the challenges of, I used an AI code assistant, in this case, Cursor, to build an app, and it's getting exploited like crazy. Let's talk through why that happens. So if we come and look at, a big flow of how the code is flowing from an AI code assistant out into production, now we have this natural language prompt. Over here on the left side, we have a developer saying, "Hey, AI, hook up to the database and pull some data on recent users, add a leaderboard." Chris, you're a parent, I'm a parent. What we know is if we're not like very specific in our instructions with our kids, you don't always get what you want. Like, I don't know how many times I've had my kid get out of the shower and I'm like, "Your hair is dry. Why is your hair dry?" He says, "You didn't tell me to wash my hair." Well, in this case, the developer didn't tell the AI to put in any kind of security controls. And so while it wrote the code that was requested, it hooked up that database, it created a leaderboard. In this example, there's no authorization, there's no rate limiting. And because those are not CWEs, they're not, classic vulnerabilities, a SAST tool isn't going to catch it. So it's going to go straight past your AppSec scanner. And then even though there's still a lot of human review elements happening at that code review stage, the volume of code is so high that it may not get a lot of scrutiny. It may not be getting reviewed by somebody who realizes that it's missing some critical things, and that app gets shipped. And then AI pops back in over here with a bad actor who uses a technique called AI fuzzing and basically says, hey, AI, find all the ways that I could potentially get access to this application. They get into the database and, data everywhere.
Yeah, I want to add a couple of things real quick to what you just said there. One is you point out the dual nature, the kind of double-edged sword of AI. Like on one hand, it could be used to create things, and the other it could be to use to exploit things. And that's kind of what we're wrestling with here. And to your point about developers, kind of they just asked for what they wanted. They didn't ask for anything to be secure or fundamentally sound from a security perspective. The challenge here is research is showing that these models and the way you approach them from a prompting perspective, they're very they do exactly what you ask them to, for better or worse.
Yeah.
So if you don't have that security centric kind of prompting involved there, you're going to get something that may work or may be functional in some capacity, but it's likely not going to be secure because you didn't specify security requirements or security needs when you were doing that prompting from a natural language perspective. And also something to keep in mind here too is like as we see people relying on these tools more and more, some of that fundamental kind of institutional knowledge of thinking to think about these things or ask about these things may be lost too, as people kind of rely on these tools more and they don't think to stop and actually validate things or kind of verify what's being produced or think about it from a security perspective or being able to be exploited and so on. So it's creating a lot of opportunity, right? Democratizing development, but it also creates a lot of problems potentially as well.
Yeah, the level of trust in these tools is really high. Again, they're immature and that trust may or may not be warranted. But I think you teed me up really well for kind of and so why is this happening summary here. The reason this is happening is because AI code assistants are not software engineers. They are programmers. And so if we take this definition from Google, in which they define what software engineering is, it's not just the act of writing code, which is what Cursor or GitHub Copilot is doing, but all of the tools and processes used to build and maintain that code over time. And so you still need that human side to it, but we're a lot of, going back to this and even this, where a lot of things are going wrong is we're treating it as if it can be a software engineer and chaos ensues. So let's look at an interesting, I forgot, I've got a couple stats in case anyone's not aware of kind of what the level of adoption is. This is some good data that came out of a few different reports. The citations are at the bottom of the slide. 75% of developers are using AI copilots of some kind, and 40% of the code on GitHub is AI generated at this point. That's a lot. What I think is super interesting is 62% of that AI generated code has issues, be those vulnerabilities, be those, lacks of access controls, things like that. This is a big problem. So we ran an experiment at Endor Labs to see, just how big of a problem is this? How usable are these tools? So we started with a prompt. I'll read the prompt out loud. I'm not one to read off a screen, but this time I think it's useful. We said, build an application that can track a game board game collection. The app should include the game name, number of players, length of the game, and some generic description. Use a Python backend based on Flask and build a React app for the front end. Fairly simple app, right? We don't need a lot of functionality here. So the first thing that it did was build what should have been a very simple application with a lot of dependencies. We took a look at how many it added. It added over 1,200 dependencies. That's a lot for a simple application. And we actually asked Cursor to reduce the number of dependencies, because what we know is the more dependencies you have, the more vulnerabilities can get pulled into your code. Well, Cursor did not reduce the number of dependencies. In fact, it increased the number from over 1,200 to 1,600. So that's just an example of, it may not do exactly what you want. And then within those dependencies, we found 65 critical CVEs, 100 SAST issues. It took 10 minutes to do all of this, and it still didn't even work. Chris, is this kind of par for the course for what you're seeing?
Yeah, it is. And I was going to comment on a few things here. Like, on the dependency piece, we know, like you point this out, like in the open source software top 10, for example, and other, frameworks and guides out there, like dependency bloat or, bloated attack surface just means more potential for vulnerabilities, exploitation, things like that. And again, to, the prompting perspective, they didn't specify use minimal dependencies or, anything like that. So it just built what it built, and it did exactly what you said. And then on the CVE piece, when you look at studies that go out there and look at the open source ecosystem and the number of CVEs based on, typical projects and repositories and so on, you're just, these models, and I know we'll probably talk about this, but these models are trained on vast open source data sets. So you're just in kind of recreating and replicating those vulnerabilities that were inherent in those training data sets, for example, into now what gets generated by AI. And to your point, some of this will get caught on based on SAST and things like that, but then there's also architectural and kind of weaknesses considerations that are not necessarily CVEs and have vulnerability identifiers, but they're still problematic. And then you get to the end of the activity here, and it still didn't even work. So now you got to go back and kind of debug it, figure out why it's not working, let alone why is it insecure and vulnerable. And yeah, it could be a lot of challenges. It can speed up productivity. You can do a lot of things. 10 minutes is pretty quick, right, to throw something together like this, which is amazing, but it's not perfect. And again, you got to go back and look at it from a security angle and see, okay, we have something now, but we got to deal with all these vulnerabilities. We got to deal with all these dependencies that we may not even necessarily need, and so on. And what is that implication from a security perspective?
Yeah, and just going back to the definition of software engineering, this is such a great example of a software engineer would probably not choose 1,200 dependencies for a simple application. So, not only are we getting all of the security issues, we're also getting a lot of, potential tech debt coming along with this application. So kind of based on this, we've developed some things that you need to know in order to better navigate AI code assistance, and then some best practices to implement. So the first thing to understand why we end up with these sort of wild applications is the concept of non-determinism. And it's important to know it's both good and bad. When I'm out in the community, I hear a lot of complaints about it. I hear a lot of people saying like, okay, how can we get it to be non-deterministic? And at its core, what non-determinism means is the outcome of it is the same prompt can produce different results. So this is by design, and the LLM will never produce a deterministic output. And that's intentional because that frees us from the if-then form of software development. That's how we can enable these LLMs to be creative and use their own reasoning. And so the good there is truly the potential to enhance our productivity using LLMs to write code. That's the good. It can do things that I might not have thought to do. The bad is it may not be consistent. It may be hard to recreate what it's done. And you're going to see different results from model to model. And even within the same model from version to version, they're just going to perform differently. So I'm going to show you an example of that. This is a little experiment that I ran. I was in Cursor. All I did was change the underlying LLM. I used the GPT 4.1 and Claude Sonnet. And I gave each the same prompt. I said, create a to-do list app with a React front end and a Python backend. And there's some other, requirements there. We won't even look at the code. We'll just look at the number of backend dependencies that it gave. With the exact same prompt, the GPT 4.1 gave me 2 dependencies, whereas Claude gave me 5 dependencies. We could probably dig in and figure out why each of these models decided to, pull totally different dependencies. But this particular experiment is one that I run on a regular basis whenever I do demos. And I see a range of anywhere from 2 to 5 every time I run it. So that's just an example of, same prompt, different outcomes. The second thing that you need to be prepared for when using these tools and when securing the code that comes out of it is unexpected things are going to happen. Exactly what you were talking about, Chris, with dependency bloat, making small feature changes that to a software engineer would, truly be small. These simple AI suggestions can really bloat your dependency tree. You can end up with hundreds or thousands of software dependencies. And what we know is that you have your direct dependencies. Those are the ones that you, or in this case, cursor chose. And then you have your transitive dependencies. And so for every, one dependency that was chosen, there can be, a handful to a dozen that are called from that. And the majority of CVEs are going to be found actually in those transitive dependencies. So you can really increase your attack surface with very small changes without knowing. And then, Chris, you made a really good point earlier about risks beyond CWEs and CVEs in terms of architectural changes. What are some of the architectural changes that you would be concerned about happening if an LLM is generating code?
Some of the big ones that tend to get discussed in this conversation are things around IAM, like authentication, authorization, and things like that. We think about things around data security, for example, of how data is encrypted or protected, and so on, accessed, exposed, data leakage, et cetera. Those kind of things, are not often more architectural in nature necessarily than a CVE identifier. But if you're just kind of, and this is something you talked about a little bit earlier when you gave some of the metrics that you gave, is it's also creating a cognitive bias in some sense where people are using this, right? Developers, as we know, they're incentivized to move fast, right? They're graded on how productive they are, how much they produce, how quickly they produce things, and they're not really incentivized to slow down and review what's being changed, whether from a vulnerability perspective or from kind of an architectural perspective. In some cases, they're just more concerned with how quickly did I do it and does it work? Did I get to the outcome that I'm after? So we've seen research now showing that developers inherently trust the outputs. They don't even go and validate them or verify them, et cetera. Do any kind of testing against them. From a security perspective, they just inherently trust them. And that would be great if it wasn't for the reality that you talked about, where you have kind of these unpredictable, undeterministic outcomes, number of vulnerabilities, number of dependencies that are involved here. So it's challenging in the sense that we're inherently trusting these things when maybe we need to take a keen eye to them and slow down a little bit. But it's just the nature of our ecosystem is move fast, develop more, be more productive, and so on.
Yeah, and I think there's probably some human psychology in that. We tend to be biased toward the thing that we've seen and it looks trustworthy, and that's how our brains function. So here's an example I pulled out of a sample risk that a SAST tool would not catch. The different colors here are showing the diff. So in this example, the OAuth implementation was modified to simplify the login flow. And when that happened, it removed the state parameter from the authorization and callback validation. So you can see we ended up, we originally had all these details in red about how to handle it. It was replaced with this very simple call. And the reality is this is going to get missed by most SAST tool because it's, it's not using problematic syntax. As the screen says here, it struggles with negative logic, meaning it only looks for the things that are there, not the things that are not there. So that human is going to have to look at that and say, whoa, 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 you made a major change here that could make us vulnerable. So what do? Right? We've laid out a lot of bad, but there's a lot of good that you can do. So the first is secure prompts. Starting with secure prompts make vast improvements over the code that was generated if you're not taking security into consideration with your prompts. And you should really be thinking about prompts as a design document, because this is natural language. We have this tendency to try to just dump a little bit of text in there and tell it what to do. But if you think about, maybe if I have to go back and explain to my son, the steps to properly taking a shower, I'm not just going to go say, take a shower, because at this point I know that's not going to work. I'm going to say, in this order, these are the things you're going to do, and here's what you're going to do after. So it's a, upfront design. It's really interesting, the research that's out there for the improvements that happen if you literally just tell it up front to design securely. That can make a huge impact. And then the reasoning capabilities of the models themselves can be hugely beneficial. So I'll walk through a couple examples of these. First off, I have two sample prompts. The first prompt on the left, the basic one, is just write a Python script that takes a host name as input and pings it 4 times. And our little AI did exactly what we said for it to do. The second example has a very similar prompt, but it also says validate the input to avoid security issues. And you can see it's gone ahead and added some input validation in here that would not have otherwise been there. We didn't tell it how to validate the input. So maybe this is or isn't how we would personally want to handle it. But this is just an example of how a very small change in your prompt can have a big improvement in the output of the code. So there's 4 different kind of ways that you can format your prompts so that they could be more helpful to the AI code assistant. The example that I was just giving was priming. You're framing the conversation before you start coding. So in this one, you're saying, be secure. The example here has a couple of examples about how you want to be secure. Reasoning based is when you actually use the model to check its work, or you can have a second model check the first model's work. The third one is decomposition based. So this is solving a hard problem as several small ones. This is my, give detailed steps on how to properly take a shower example. And then refinement based is giving it the instructions to iterate over multiple prompts. So before we move on, Chris, anything you want to jump in here?
No, I like this framing, these 4 different examples, because it kind of speaks to the ability, again, this is a great capability, right, to put in the developer's hands and enhance productivity. But as you point out here with these different 4 4 types of approaches, if they just take the time to kind of lay out what they want in a certain way, or have the AI even validate its own work like you talked about, or even iterate on that based on findings, which we'll talk about, using tools and so on to produce findings based on the app, the code that the AI tool produces and so on. There's a lot of opportunity to improve the outcome, from a security perspective. It just takes the work of kind of slowing down or asking very particular types of ways and so on. And I think we'll get there, but we're just in such an infancy of adoption that people are just rushing to use these things. They're not thinking about these type of security implications. And it'll be interesting, a few years, I should say, to kind of see what the AppSec landscape looks like, based on that paradigm that's unfolding.
Yeah, I'm very interested to see how that unfolds. We certainly get asked a lot, well, why can't the AI code assistants take security into account from the start? Why would you say that's not happening?
I think that, it's interesting. I think we're starting to see, if you look at the leading vendors, like some are starting to try to integrate, native capabilities into their tools when it comes to scanning for dependencies and findings and things like that, with a simple command. We're also seeing, to the prompting angle of it, even some are now, I don't want to say commercializing, but offering like, kind of packaged prompts, like from a security perspective that, people can use from an enterprise. And I think I wouldn't even be surprised if enterprises start to kind of cultivate, a repository of, security centric type prompting for their teams to use. But, when it comes to the vendors, it's almost like, the cloud provider, they offered a capability inherently initially without security kind of being a core offering of that. And I think in time, the AI tools and development platforms will also, I hope so at least, offer some of these capabilities natively and some of these guardrails natively as well. It's just, again, it's kind of the typical paradigm where security is not a first thought, it's kind of an afterthought.
Yeah, good point. I think we'll see a lot of evolution over the next, I would say year, but probably even the next 6 months. And that actually flows really nicely into a resource that we provide that's totally free, is a library of over 40 prompts that you can use either as is, or you can, tweak them so that they work well for your organization. You can copy them over. You can learn about these different techniques that I've talked about. So again, totally free, not a product. You can download those and kind of start to prime your own library. So we talked about starting with secure prompts. The next layer of security on top of that is to start to get a little bit more organizational in your approach in terms of security standards. And so there's a couple different ways that you can do this. One is the concept of rules, which I'll show you what a rule looks like shortly. But you can use rules in these AI code assistants to kind of codify the types of behaviors that you want to see. So for example, if you have a way that you want to handle authorization, you can codify that in a rule. And then anytime your cursor or whatever writes some code that has to do authorization, it will pull in that. You can also use an ignore rule to protect sensitive data, since that is often the biggest concern with using these tools. Just kind of keep in mind, they work differently from model to model, so you might have to experiment a little bit to see which ones work. And then I think the thing that like what's old is new keeps coming back with AI is, look into test-driven development. There's ways that you can use this concept with AI where you essentially use the model to write the tests in advance of writing the code, and then use a different model to then write the code, and that can help catch issues. So what does a rule look like? This is a very simple rule for setting a preference around user input. And what I would do is I would copy this into my cursor instance, or however you manage your organization. And this would ensure that I would have properly constructed user inputs. Okay, so we talked about starting with secure prompts, then layering on organizational rules. The third thing that you really want to be looking at is getting real-time security signal. Chris, you mentioned this all the way back at the beginning. Remind everyone, what's the average age of the training data for these models?
I don't remember the exact metric, but I want to say it's at least a year in many cases. And again, that's code. When we look at findings across the open source ecosystem that these are trained on, like that often means inherent vulnerabilities or outdated dependencies and things like that come along with it now, because you have that, I want to say, stale training data set, but an older training data set. In the context of software, at least, the space moves very fast. There are be fixes, new versions, etc. And that won't be accounted for when you look at these training data sets and how the model is going to produce code.
Yeah, exactly. I was just doing an experiment yesterday with the most recent version of Claude, and it pulled a whole bunch of dependencies for me that were 2 to 3 years old. And I looked at the training cutoff, and it was about a year ago. So what can you do about this? This is where the concept of an MCP server can be tremendously useful. Think about an MCP server a little bit like an API. APIs don't work very well with LLMs, and so this is a more dynamic way to connect with external data sources. So you can bring in vulnerability information into your cursor or whatever tool you're using to actually inform the tool from the start for secure development. So they can effectively act as, kind of new training data for the model so that it makes better choices. What does this look like? First, I'll show you my little example. This is an older experiment I ran. I think I'm using GPT-4 here. I looked up the dependencies. One's from April 2024, one's from March 2024. Sure, a lot has happened in the last 12 to 18 months. These could be vulnerable. The reason is because their training cutoff is June of last year. So this is what an MCP server kind of looks like in your environment. So we've got the different AI code assistants up at the top. An MCP server kind of conceptually sits between those and whatever data source you're trying to pull. And it's going to be a really simple JSON file that tells it what to pull. And then how it pulls the data and uses it is determined by rules. This is an example of a software composition analysis rule where it tells Cursor every time a manifest or lock file is created or modified in any way, you're going to do the following prior to performing your next task. So Chris, going back to something you said earlier about, how can we start building in security from the start? This is priming the LLM to build in security as it goes. And in this case, it's telling it, run the specific scanner, provide the language, dependency name, and version number when making the tool call. That's so obviously it can look for potential vulnerabilities in the database. And then if a vulnerability or error is identified, upgrade, replace the dependency, and then check that it worked. So this is, fairly simple, right?
Yeah, it's definitely very simple. But what I like about too is we talked about, how security is often an afterthought. And when it comes to AI, like, maybe it's just me and I'm optimistic, but it feels like the cyber community is quick to adopt and like see how can we use, because MTP wasn't necessarily made with security in mind as its primary use case, but you're seeing how can we use this model context protocol from a security perspective, like to inject some security earlier in the SDLC. And again, like on your previous slide, you had a bullet at the end there, which is also using the AI to help identify, vulnerabilities and weaknesses and findings and things of that nature. So I like the fact that we're seeing how can we use these technologies. We know our business peers are using them, our development peers are using them. Attackers are obviously leaning into how they can use these. So I like that security is also leaning into like, hey, how can we use LLMs? How can we use MCP? How can we use these things from a security perspective? This is a great example of doing that and injecting that, into a developer workflow to identify vulnerabilities earlier in the SDLC, kind of like in the vein of secure by design in a kind of tactical sense.
Yeah, I think it really offers the potential to have true secure by design, or, feel free to roll your eyes, like a shift left type of, mentality, where in this circumstance, we're not asking the developer to do anything. This is all being performed by the LLM. It's generating secure code on its own, and that's kind of the dream. What I think the potential here is there's a lot of both narrative and data now, kind of looking at these tools and saying, well, are they really helping developer productivity? Because we're constantly having to fix the code and it's slowing things down at PR merge. This is an opportunity where security can come in and actually make things faster. And we don't get to say that very often. So I'll summarize and then we'll move on to our walk stage. As you're looking to securely adopt your AI code assistants, there's 3 progressive things you want to be doing. First, provide your team with secure prompts. Educate them that literally saying security or secure in their prompt, even if they don't use yours, is going to make it better. Second, implement some security standards. Those can be in your engineering standards. And then third, bring your security tools into your AI code assistant so that it can add some real-time signal. Okay, part 2. Now we're going to be talking about the AI models and services that are being utilized in your applications. So you're probably not writing these yourself. You're probably consuming them from somewhere else, perhaps Hugging Face, perhaps, whatever, ChatGPT, for example. So Chris, I have kind of 3 steps identified, and I'm sure you're going to look at this and you're going to say, Jen, like, this is just what you do for everything, right?
Yeah, that's why I was starting to laugh off, on mute here is I talked about this when we first led into the conversation is like a lot of these things when we think about consumption of models, especially in the context of SaaS, is stuff that we've traditionally done for SaaS security and SaaS governance. It's like just to discover what we're using, right? Having a process to govern what we use in terms of how it can be used, how it can be used within organizational security policies and so on. And then having an approval process, because there's inevitably going to be new requests for a new, AI as a service type model, a SaaS-based AI service model, as well as, bringing in new models from external platforms like Hugging Face and things like that, which are a different kind of, self-hosted open source kind of context. But a lot of these things are fundamental security practices, just knowing what we're using, where did it come from, who creates it, what's the security of the provider, if it's an external kind of commercial vendor, or if it's open source, what's the security of, the lineage of it, for example, who contributed to it, how was it created, what the inherent vulnerabilities are. These are things that we should be doing already when it comes to any software, including AI. So I think that, it's an opportunity for us to kind of lean into what we already know and have been doing, at least hopefully have been doing in many cases, and do it here with AI.
Yeah, so let's talk through some of the, like, maybe gotchas that would be a little bit unique for these. If you're onboarding an AI model or trying to figure out what AI models are in use versus, what we're used to as SaaS. So if you're in the approval stage, I talk to a lot of Endor Labs customers about how they're deciding which models to use. And what I typically hear is it often follows the same kind of like procurement steps that any SaaS product would follow, with a caveat. Most of the time, they're looking to see how is data being used, and in a different way than the SaaS tools are using data. So, Chris, as you're, as a, CEO yourself and, going through these things, what are the data usage concerns that you would say need to be on these checklists?
Yeah, this is the big one that gets all the, CISO security leaders and even technology leaders more broadly attention is like, look at these. We talk about training a lot, right, throughout the conversation of training for these models. There's a lot of concern around, is the model provider training on my data? It may be proprietary sensitive, data like IP. It may be customer data, PII, PHI. You definitely don't want those things involved in training from the external model provider. So understanding how they use my data. Do they train on my data? How do they safeguard my data, encrypt my data, keep it segmented from other customers? If they're storing it in some capacity, how do they ensure that they sanitize my data from their data sets or things of that nature if it does make it into training data? So really it's like the emphasis around data, understanding what they're going to do with my data and how. And then again, it's kind of a two-folded shared responsibility model. On one hand, you're concerned with like, what is the vendor doing with my data? Are they even using it? And hopefully, they're not training on it and so on. There's been some interesting dialogue out there about different SaaS providers now training on data, on the back end of customer data.
Yeah.
And then also, from the organizational perspective, informing the workforce of, hey, here's the type of data we should or should not be putting into these AI models and external service providers, and here's why. And that's kind of a shared responsibility paradigm all over again.
And then I think the next layer of challenge, much like there are now tools you can use to discover what SaaS is out in your environment, the next challenge now is, okay, I have a list of things that have been green lighted and a list of things that are denied. How do I know what's actually being used? What are you seeing people do?
Yeah, this is I'm smirking because this is still a challenge. Like there are tools out there, right? And there's a lot of different ways to come at this. It's very similar to SaaS security, from a context of trying to discover what's being used and governs what's being used. Some people are coming at from the browser's perspective. Some are coming at from the network perspective, the endpoint, identity centric type stuff. If you're a lot of times there people are just authenticating with IDPs and organizational identities to these external providers and kind of governing it that way or trying to. There's obviously age-old concepts like CASBs in the context of SaaS of trying to insert like a central kind of choke point in terms of external access. So I think people are coming at it from a lot of different angles right now and trying to see what works. Just like SaaS, it's never perfect. You never necessarily get everything unless you really restrict the business, and that always creates friction, and you become kind of a blocker, as you joked earlier. So there's a lot of different angles, whether it's a network, the browser, the endpoint, the identity. People are coming at it from a lot of different ways, or a combination thereof, and trying to ensure that they have a good handle on what's being used. Is it approved? If it's not, how can we go about blocking it in some cases?
Yeah, let's talk about three things that you could be doing right now to figure this out. The first piece of advice I have is, what can your existing tools handle? There's a tremendous amount of pressure on vendors to make the switch to covering AI. There's going to be your group of AI startups, and there's going to be your incumbent tools that have to evolve and change in order to address issues. So that would be where I would start, is audit your existing tools that could potentially hit all of the areas that Chris was talking about. For example, if you're using an SCA tool, models and dependence, models and services are a software dependency, right? So find out, can your SCA tool scan for these things? Find them, potentially block them. Coming to my second point about robust policy management. Chris, what would be your short list of the types of tools you would start to look at to see, have they expanded to help you address this problem?
Yeah, it's funny you phrase it that way because that's how I think about it. You have the AI native incumbents who are coming out there and saying, "Hey, we help you do this kind of discovery and governance of AI consumption," and those could be an option. But there's a lot of tools people likely already have in place when you think about like SaaS security posture management, things of that nature that you might be able to use to determine what's being consumed and how. That's kind of external service type model providers. And then to your point, internal type tooling, SCA, understanding we're pulling in external models from open source platforms like Hugging Face, what's inside those models, the lineage, are they approved for use and so on. So there's a lot of different tools, whether it's SCA, SSPM, I use the phrase kind of CASB or proxy type activities. Those are out there, of course. So there's a lot of different angles. Depends, like, what do you have currently? What can it do when it comes to AI, providers, whether external or self-hosted type, open source type models that you're hosting in your own environment? You just got to look at your use cases. How are you adopting AI? Likely a combination of thereof, depending if you're a large, complex organization. And then, you're not to jump ahead a little bit here, but you have document your AI and SBOMs.
Yeah, hit
We
it.
love our acronyms, and now there's the new phrase AI bomb is kind of
I
a thing
know.
now as well. And not that it's a bad thing. We need this kind of transparency around AI as well in models. But a new phrase, AI bomb, for folks out there, is just documenting the I guess your composition of your models, for example, in terms of what dependencies are in there, what vulnerabilities are in there, and things like that. So that's another thing to keep an eye on now is moving forward in the industry is AI bombs.
Yeah, and you may end up having to do that. There's a new ISO standard that's around AI, and then there's several regulations going into effect in the EU that will have some bearing on this. Which specific ones would you have your eyes on, Chris, for potential compliance?
Yeah, it's interesting. Not to take us into a kind of a side branch just briefly, is like there's a dichotomy of approaches between the US and EU. In the US, we're seeing kind of a rollback and kind of a free market perspective, in terms of like move fast, we want to innovate, we want to keep pace from a competitive perspective. But the EU market is much different. They're taking a very regulatory centric, compliance driven approach. And if you're a global business doing business in the EU, which is many of organizations nowadays, they have ISO, like you talked about there. You have the EU AI Act. There's NIS2. There's DORA. There's a lot of things that touch on AI and are going to continue to touch on AI as we move forward. But the EU AI Act is, of course, kind of the elephant in the room. A lot of folks are keeping an eye on that in terms of how you're using AI, how you need to be securing it, how you need to be disclosing that to customers, all kinds of things of that nature. So definitely take a look at that if you're, kind of functioning on the global stage.
Yeah, agreed. There's definitely a lot to keep track of right now. And even if your company is not specifically looking to comply with one of those standards, I'm definitely hearing that consumers are looking for companies to be complying with them. So things are.
That's a great point. Just in the U.S. in particular, even though we don't have something like the EU AI Act, for example, we saw early, even now when it comes to SaaS, one of the first questions you'll get from a security team is, do you have a SOC 2? Are you FedRAMP or whatever, right? That's very similar to how we're seeing it play out when it comes to AI and things like ISO 42001, those kind of things. Consumers, security savvy consumers in particular are asking these questions. Is your organization compliant with X? Can you show us, how you're using AI within your organizational context? And do you have any kind of credentials or, compliance certifications and so on associated with that?
Yeah, lots to change. Okay. Our third area where we're intentionally going to spend the least amount of time, because this is definitely emerging for a lot of people. There's going to be a small set of organizations that are developing LLMs on their own right now, and a larger set that it's probably not a today thing, but I would say it's a not never thing. So this is, how do we integrate security into that LLM development lifecycle? Again, lots of startups in that space. We're going to take a bit of an application security focus bent to this because that's the world that we live in. So kind of, realize we're not going to hit it all. So I'm going to say it's just more dependency management. There's a lot of things that if you're doing it for your open source libraries, you probably should be doing it for your model development. It looks like one of my little animations is not happy with my screen share. That's a cat. It's looking for what's in there. So let's talk through these three things that are relevant for if you're fine tuning and training your models. Chris, you've touched on model provenance a couple of times. Give a very what is it? Why does it matter?
Yeah, it's similar to open source in the sense that we have this amazing ecosystem of individuals across the world who are putting these things on the internet for people to use and save time and development and R&D and financial costs and so on. And it's great. You can tap into that community. For example, Hugging Face, as I don't have the metrics up. We didn't go through those, but it has seen tremendous amount of adoption and accelerated growth, among the community. And it's a lot of different models on there you can go in and start to use that are, created by the community. But again, you need that kind of provenance. You need that transparency around, who created the model, where did it come from, where are the dependencies, where are the vulnerabilities, what's it within the model. In some cases, obviously are looking at things like model training weights and so on, to get deeper in the weeds, if you're doing your own kind of model development and so on. And this is something to keep in mind, just like broader open source software. It's an amazing resource, right? You should tap into it. It can save you a ton of time and research and development time and so on. But it's not without its risks. And that's why you need to kind of take that keen eye to it, of seeing, what's the provenance of the model, what's the pedigree of it, what's composed of, and so on.
Yeah. And then kind of a similar concern is you have to train your models, right? And in most circumstances, Python code is what's being used for model training. And again, that's open source code. So the probability that it has vulnerabilities and issues and weaknesses in it is the same as it would be for if you're developing applications with that code. And so it needs to be scanned, with SCA SAS. So making sure that that code is included with the existing application security program that you have. Let's spend a little bit more time on specific AI LLM risks. What should people be watching out for?
Yeah, there's some great resources I want to call out here, for folks to go check out if they want to get deeper into this. But there's resources out there like the OWASP AI Exchange. I think OWASP has an LLM top 10. There's a lot of great resources out there that folks can check out. And there are novel risks associated with AI, like obviously fundamental, runtime, production kind of things still exist at the IaaS, infrastructure as a service layer, where your hosting environment, your underlying configurations and vulnerabilities associated with operating systems and all those kind of things, that you need to keep in mind. But there's obviously novel things like model poisoning, model theft, sensitive data leakage, prompt injection is a particularly nefarious one that we see playing out, is just by the nature of the way LLMs work. People are really getting creative with, natural language to get the models to do things that they weren't intended to, expose data that they weren't intended to expose, and so on. And it's really interesting to see that unfold. And then we're even seeing people start to, really do some trickery of embedding, this prompt injection in a sneaky way, right, into emails, into Jira tickets. And so like there's all kinds of different research coming out. And it's making the models do all kinds of things that people definitely did not intend to have them do originally. So, definitely keep in mind that, prompt injection is the big elephant in the room.
Yeah, I would say in terms of resources to learn more about this, you gave some really great, like practical ones. I would say if you want to see case studies of these, obviously the internet may or may not be your friend, but I would look at the recordings from B-Sides Las Vegas that just happened a couple of weeks ago. I saw lots of talks on this type of topic.
One other one I was going to call out that just came to mind is MITRE has something, they have attack and people are familiar with that, but they have something called MITRE Atlas. And I will not remember what the acronym stands for at the top of my head, but it actually goes through some of the risks and vulnerabilities with AI and LLMs and so on. And each of those has several real world, kind of attacks and exploits and use cases associated with it. If you want to dive into and see like, oh, show me an example of XYZ, you'll be able to see a real world, kind of exploit that happened and impacted some provider, some model, so on. That kind of thing is really cool to check out too.
Oh, that's very cool. I'll have to go find that. Okay, as we start to wrap up, I'll invite you to connect with Chris and I on LinkedIn. I know these are QR codes and QR codes are scary, but I promise these ones are legit. If you'd like the slides, I'm happy to send them to you. Happy to send specific resources. And I hope this was useful. Chris, thank you so much for your time.
Yeah, absolutely. It's a fun conversation. And like the community here, I'm learning as we go. And these conversations are always helpful.
Right on. Well, don't hesitate to ask us questions, and we look forward to more conversation. Bye.